Today's video covers section 510. The book calls this section Simplifying Expressions Containing Complex Numbers, but in reality it's a section on dividing complex numbers. And so henceforth we will call this section Dividing Complex Numbers. And I give you this example, 8i over 1 plus 3i. And we can't stop here. We're saying 8i divided by 1 plus 3i. We can't finish this. We can't say that this is a finished answer for a pretty serious reason. Why? Well, if you suggested that the problem is with the fact that I is equal to the square root of -1, and henceforth we are talking about a square root in the denominator, you're exactly right. How in the earlier sections in this chapter did we address the problem of a radical in the denominator? We multiplied by the conjugate. Here we're going to multiply by the complex conjugate. It's no different than any other conjugate. We're just changing the sign in the middle. So we're about to multiply top and bottom by 1 minus 3i. And so we do it. We have 8i over 1 plus 3i being multiplied by 1 minus 3i in the numerator, 1 minus 3i in the denominator. Let's do the multiplication. Distributing across the numerator gives us 8i minus 24i squared. Foiling in the denominator, 1 times 1 is 1. 1 times -3i is -3i. 3i times 1 is plus 3i, and 3i times -3i is -9i squared. Just like we had in the earlier sections with multiplying by the conjugate, the outer and the inner term drop out, and as a result there's no more imaginary number in the denominator. As soon as we do that, we've eliminated the imaginary number. It's the only situation, unless we had other radicals involved, it's the only situation in which we would have had any square root or any root of anything in the denominator. We won't cover any problems where there's other square roots in the denominator, so don't worry about that. Realize that I squared is -1, so we'll take that I squared and we'll turn it into -1, so we're really subtracting 8i minus -24. 24i squared is -24. Combining like terms in the denominator, as we said, gets rid of the outer and the inner terms. We have 1 minus 9i squared, or if you prefer, we can call that 1 minus 9 times -1. That ends up being 1 plus 9. The denominator is 10. 1 plus 9 makes 10. So in the numerator, subtracting -24 is the same as adding 24. And that 8i came along for the ride the whole time. So we have 8i plus 24 in the numerator all over 10. Are we done? Should we be done? No, there's actually one more thing we can do. Notice that the coefficient on I and what's being added to it in the numerator, as well as the denominator, they're all even numbers. They're all divisible by 2. So let's factor out a 2 from everything. 8i divided by 2 is 4i, 24 divided by 2 is 12, 10 divided by 2 is 5. So we would leave this as 4, we get to a final answer of 4i plus 12 over 5. Or the preferable way to write it is with the real part first. So 12 plus 4i over 5. Or if you want to be really different, you could write the answer as 12/5 plus 4/5 I. You can write it that way if you are so inclined. You don't have to. You're going to see in all of my answers that I stick with it looking like this. And you can too. Here's another example. And this time it's a little bit different. It's not a binomial in the denominator. There's only one term, 5i. This is actually an easier type of problem because we don't have to do any foiling here. But we do need to get rid of that I in the denominator. And you would say that, oh gee whiz, let's multiply top and bottom by negative 5i. That's an obvious place to start. Negative 5i would be the complex conjugate of positive 5i. We don't need to do that. When there is only one term, and this rule that I'm about to say only applies when there's one term, multiply the top and the bottom by just I. So now we have 2 plus I multiplied by I in the numerator. The denominator of 5i is being multiplied by I. I times 2 is 2i. I times I is I squared. So we have 2i plus I squared in the numerator. Multiplying in the denominator, 5i times I is 5i squared. But remember, all those times that we see an I squared, it's really negative 1. So we'll turn the plus I squared into really it's a minus 1. And because I squared is negative 1, we really have in the denominator, instead of 5i squared, we have 5 times negative 1. So cleaning up the numerator and denominator a little bit, we have 2i minus 1 over negative 5. And if you want to stop here, that's fine. However, as a general convention in math, we don't like to have a monomial denominator that is negative. We also don't like, in general, the fact that in the numerator we have the imaginary part first. So what we're going to do to take care of both of those problems, in the denominator, we're going to change it from negative 5 to positive 5. We're going to factor out a negative 1 from everything. So pulling a negative 1 out, we're just going to change the sign on everything. Negative 5 becomes positive 5. We go to the numerator, and the real part comes first. Negative 1 is about to become positive 1, followed by the 2i. Change the sign on that as well, and we finish with 1 minus 2i all over 5. Here are two problems for you to do. 9 plus 3i over 2i, monomial, and 5 over 1 plus 2i. Do both of those divisions, and I'll be back in a minute to see how you did. So the first problem, we have a monomial denominator, and we'll multiply top and bottom by I. And remember that the numerator is a binomial, so we're going to be using distributive property. I times 9 is 9i. I times 3i is 3i squared. And the denominator, 2i times I, is 2i squared. Clean this up a bit. Adding 3i squared is really the same thing as subtracting 3, and 2i squared is really the same thing as negative 2. So we have 9i minus 3 over negative 2, or if you want to play the sign change on everything, denominator changes from negative to positive. The real part goes first and changes its sign, so negative 3 becomes positive 3. The imaginary part goes second and changes its sign, and so we have 3 minus 9i all over 2. The second problem that you were asked to do was 5 over 1 plus 2i. This is a binomial in the denominator, so we will multiply the denominator by 1 minus 2i. But if we do it to the bottom, we must also do it to the top. And so there is foiling to be done. That says 2i in the numerator, by the way. There's foiling to be done in the denominator, and there's distribution to be done in the numerator, and we'll take care of those. 5 times 1 is 5. 5 times negative 2i is negative 10i. In the denominator, 1 times 1 is 1. 1 times negative 2i is negative 2i. 2i times 1 will add 2i. And 2i times negative 2i, be careful here, it's positive times a negative, so the result will be negative. Negative 4i squared. There's your denominator. Couple things to remember. The inner and the outer terms will cancel out as always. The denominator becomes 1 minus 4i squared, but the negative 4i squared, that's really saying plus 4. And in that case, the denominator is 1 plus 4 or 5. We have 5 minus 10i over 5. And if you're saying, oh, we're not done because these are all divisible by 5, you are right. 5 goes into 5 one time. 5 goes into 10i 2 times. So we have 1 minus 2i over 1, or we'll just call it 1 minus 2i.